So in this video, we're going to be looking at the exact same lessons as the previous video, but now we're going to look at the word problem. So we're going to apply the math we were using in the last classwork to real examples. Okay, so starting off, we're going to look at 12.5, which is where we use right triangles, remember? So we're solving right triangles in this lesson. And so all of our triangles that we're going to draw for our word problems on the classwork and in this video are going to be right triangles. Okay, so they should have a 90-degree angle somewhere. So let's look at number 6. It says the approach pattern to an airport requires pilots to set an 11-degree angle of descent towards the runway. So we stop there. So when it says 11-degree descent toward the runway, that means that the angle between your descent, so let's say this is the plane's descent, and the runway itself, this angle is 11 degrees. Okay. The plane is flying if a plane is flying at an altitude of 9,500 meters, at what distance, measured from the ground, from the airport, must the pilot start the descent? So this corner here at the end of the runway, this is our airport. The top of our descent here is our plane. And the distance from the ground is 9,500. Okay, and so essentially what we need is this value here along the ground. So what we're going to do is use SOHCAHTOA because we've got a right triangle here. So tangent of 11 degrees is equal to 9,500 divided by x. Okay. So this is x equals 9,500 divided by tangent of 11 degrees, which is equal to 48,873 when we round to a whole number here. Okay, but we want 3 significant digits, so we're going to round to 48,900 meters. And that's it. Okay, so in this problem and number 4, we got lengths, so that's why I rounded to 3 sig figs. In the first problem, number 2, I was getting an angle, so they say round that to the nearest tenth. Now let's look at 12.6. In 12.6, we were looking at law of cosines. Okay, and so we're going to use those to solve our word problem. So our triangles are not going to have 90-degree angles, otherwise we would be using right triangles, not law of cosines. So let's look at number 2. It says 2 planes leave an airport at the same time, one flying due west at 500 kilometers per hour and the other flying due southeast at 300 kilometers per hour. What is the distance between the planes 2 hours later? Okay, so first thing I'm going to quickly review with you guys is a compass. Okay, we have north, west, south, east, right? If you notice, the angle between each direction is 90 degrees. That's on purpose, okay? So our first plane is going directly along the western direction, okay? But our second plane is going in a southeast direction, which bisects our quadrant of south and east. So the angle is going to be 45 and 45 degrees, okay? That's important to remember for later on, because if we have 45 degrees here and then 90 degrees here, 90 plus 45 is equal to 135 degrees. So let's draw this triangle a little bit larger. So we've got brown being our first plane, okay, and then green being our southeastern plane. And so this angle is going to be 135 degrees in the middle there, okay? Now, the second thing we need to figure out is how big of a distance did each of those planes travel in 2 hours, right? So distance is equal to rate times time. So distance of plane 1, so let's just name that D1, is going to be equal to 500, right, because it's going 500 kilometers per hour, times 2. So it'll have traveled 1,000 kilometers. So this brown line is 1,000 kilometers long. Distance 2 from the airport, because the airport's the center portion right there, in case you're wondering, is going to be 300 kilometers times 2, since it's going 300 kilometers per hour. So this is going to be 600 kilometers. Okay. What we want to know is the distance between them, so that would be that dotted line right there. So this is what we're looking for, D right there. Okay. So remember that the formula for cosine, there were 3 different types, right? Our general formula we're going to be using for these word problems is d squared is equal to, let's name it x squared plus y squared minus 2 times x, y, cosine of your theta. Okay, so what we're solving for is here is d. So we're going to leave that as is, but it's going to be d is equal to the square root x squared, let's just make that 1,000, okay, squared plus 600 squared, because that's our second distance, minus 2 times 1,000 times 600 times cosine, and our theta here is 135. Okay, and so this will be equal to 1,486.1. Again, we want to round to 3 significant digits. This will be 1,490 kilometers. And that's our answer. Now let's look at 6. We're still doing law of cosines here. It says, an oil tanker and a cruise ship leave port at the same time and travel in straight line courses at 10 miles per hour and 25 miles per hour respectively. So the oil tanker, let's make that bright green, is going to be doing 10 miles per hour. And the cruise ship, let's make that a blue, is going to be 25 miles per hour. Okay. They leave port at the same time and they travel in straight line courses. So let's draw our port. Let's say this is the direction of our oil tanker. So I switched colors again on you, sorry. And then this will be the direction of our cruise ship. Okay. 2 hours later, they are 40 miles apart. So this distance in between them right here is 40. What is the angle between their courses? Okay, and that is what clued me into the fact that I drew them the way they are. They aren't the way they are. So the angle between their courses would be this angle right here once they both leave port, right? Because they're not going in the same direction. They're so this is going to be what we're looking for, x, or as I wrote it in the notes, theta. Okay. So what we need to figure out is, just like with number 2, we have to figure out how far did they actually travel, because these are lengths that the arrows are representing, and what we have are rates. So we need to find the actual distance each of these traveled in 2 hours. So distance 1 of the oil tanker, so let's do DO, that's going to be 10 times 2, so that's 20 miles. And then D of the cruise ship is going to be 25 times 2, so that's going to be 50 miles. Okay, so we have all of our sides, and what we're looking for is our theta. So we're going to use the same general formula we used last time. So that's going to be d squared is equal to x squared plus y squared minus 2 times x times y, cosine of theta. So we're going to have 40 squared plus 20 squared, equals 20 squared plus 50 squared minus 2 times 20 times 50 times cosine theta. Okay, so we end up having 40. I'm just going to do the algebraic part. I'm not going to actually write out the numbers once I plug them in, because I'll do that on my calculator. Divided by negative 2 times 20 times 50 is equal to cosine theta. So then we have that cosine theta is equal to 0.65. We're going to use inverses here, so you're going to do theta is equal to cosine negative 1, that button on your calculator, of 0.65 which will be 49.5 degrees. And that's the answer. Last one we're going to look at is 12.7, which are the word problems when we're using law of sines. Okay, so we've done right triangles, we've done law of cosines, now we're going to do law of sines. So number 4 is where we're going to start. It says a college football pennant is the shape of an isosceles triangle. Okay, the base is 16 inches long and the sides meet at an angle of 35 degrees. How long are the sides? So remember, an isosceles triangle, let's draw it upright instead of on its side like a pennant would be. Okay, the sides are the same length, remember? Okay, and so the sides here that I just tick marked meet at a 35-degree angle, and the base is 16. How long are the sides? Well, what's a nice thing we can do is we actually don't even have to use law of sines. We can actually just divide this isosceles triangle into 2, and that creates a right triangle when we bisect it. So we're going to take this little portion right there. So actually I'll do that in a highlighter color. Okay, so we're going to then put this out as, here's our right triangle, okay. This is the angle 35 divided by 2. This is the base divided by 2, right? So that's going to be 8. And what we want to find is this value here on the hypotenuse. So we can use SOHCAHTOA. So we'll do sine of opposite of that, of 35 degrees divided by 2, will be equal to, opposite is 8 over x, so x will be equal to 8 over sine of 35 degrees over 2. So this will just be 26.6 inches. And that's it. Okay, so we actually didn't have to use law of sines in that example. Last example we're going to look at is number 6 on 12.7, okay? So it says 2 surveyors are on opposite sides of a swamp. To find the distance between them, one surveyor locates a point T that is 180 meters from her location at point P. The angles of sight from T to the other surveyor's position R measure 72 degrees for angle RPT and 63 degrees for angle PTR. How far apart are the surveyors? So that's a lot of information. So let's break this down. First things first, we've got 2 surveyors on opposite sides of a swamp. This is my swamp right here. Okay. So we've got one surveyor at point P. Let's put her on that bank. Okay. And then we've got another surveyor at point R. So we'll put them on that bank. The surveyor at point P found a point T that is 180 meters from her location. So let's say that's over there. Okay, so this distance right here is 180. And then what they're essentially doing, the surveyor, is they're using trig. So they're going to make a triangle between the 3 points. So we go here and there. Okay, now then it says the angles of sight from T to the other surveyor's position R measure 72 degrees for angle RPT. So RPT tells me the angle at the vertex P is 72, right? Remember from geometry? And then it says 63 degrees for PTR. So the angle at vertex T is 63. How far apart are the surveyors? Well, first thing I'm going to do is I notice that I don't have the angle opposite my side, and so I can't use law of sines without that. So I'm going to find my third angle. The one that goes PRT. So angle PRT is going to be 180 minus the sum of the other 2 angles. So that's 72 plus 63. So this will be equal to 45 degrees. So I'm going to mark that. Okay, so now I have the angle and its opposing side, and then I can find my side that I want. Now there are 2 sides to choose from. Remember, T is not where a surveyor is. P and R are. So we want the distance between P and R. So this means we're going to be looking for sine of 63 degrees over x, because that's the opposing side. here, and there, is going to be equal to sine of 45 divided by 180, because those are opposing sides, here and here. And then I'm going to cross multiply. So I get 180 times sine of 63 is equal to x times sine of 45. And then to solve for x, I'm going to divide by sine of 45. So I get 180 times sine of 63 over sine of 45 is equal to x. So I get that x is equal to 226.8. Again, we only want 3 significant digits, so that's going to be 227 meters. And we're done. Okay, so the classwork due the 6th, so that's Thursday for F block, and the 7th for C block, is page 578, 1 through 7 odd, page 583, 1 through 7 odd, and page 589, 1 through 7 odd. So in total, it's about 12 problems. They're all of the word problems. Okay, you're going to need your calculators, obviously, because these numbers do get big and there are non-standard angles. And then, just as a heads up, test 18 on these two sections, well, these two lessons, is going to be Monday the 10th for F block and the 11th for C block.